uh, make sure that you know, you don't hesitate, right? The point I
Sure.
want to make is that you don't hesitate. No question is bad or small or stupid for me. You can ask any type of questions. If you don't understand in first go, I'll explain it twice or thrice till you don't understand. All right?
Yeah, sure.
So rest assured about that. So feel free to ask questions. That's very important. Okay?
All right.
And then I would be also giving you exercises on the topics that we study. So make sure that you do the exercises very religiously, because
Mm-hmm.
if you don't practice, and you know, we'll keep on moving ahead with our course, and if you fall behind on the exercises, it will be little difficult on catching up, because what will happen that, you know, I'll be covering new topics and you will still be stuck with old ones, and then that by the time the course completes, you will still not be able to complete all the topics.
Yeah,
And
that's for sure, and that's the basic of like learning programming.
yes, true. So the basic theoretical concepts are one aspect of it, and programmatical concepts are other aspect of it. So that, I think by now you might have figured it out. Yeah,
Okay. Yes.
perfect. I just shared my screen. Please let me know if you can see it.
I can see the PowerPoint now.
All right, great. So we'll start with something called as OOPS concept, right? Which is basic of any high-level programming language starting from C++. So initially we had all low-level programming languages such as C and JavaScript and you know, Python, Perl, CGI. So those were other programming languages used in lot back days, and from there things has, you know, changed, and all the programming languages that were developed after C++, they were all based on what we call as the OOPS concept, which also stands for object-oriented programming concepts. Okay? So any programming language that you see nowadays, they are all based on object-oriented programming concepts, whether it is C++ or Java or .NET, right? Or what else are the languages? Ruby, C Sharp, any language you take that are existing nowadays, they're all built on OOPS concept. So it is very important that before we start learning any programming language, we should know the basics, right?
Right.
So let me ask you, during your self-study, did you go through the OOPS concepts?
I went through some of these C# concepts when I developing with .NET.
Okay. So tell me, what is OOPS concept then?
The ops concept is like how I can say it. It's just making like an object, or like every programming can be embodied in object, like rectangle, circle, like laptop, like car, anything. Everything we can just make it like an object and put something inside this object, like a box.
Perfect, perfect. So your concept is very clear. So object-oriented programming means programming language which is centered around objects, right? So anything that you write in your code, that has to be around an object. It cannot exist without an object. Okay? Now, having understood that point, let me ask you another question. Why objects? I mean, what is so peculiar about objects that we have to write everything in and around objects? I mean, why can't we write code without object?
Well, I think that is because as a human, we cannot follow up with everything. We need an entity to refer to before we do something with it, like a house, like people, like company, so that we can make the company grow, or make the people move, or make, like, you know.
You're right. So you are very much close to the correct answer, but I would put it in this way. So, or rather, let me ask you, why do we write programs?
And just to make the software efficient and make a new product to the computer.
Right. So new product, the product would be, say, some banking system, right? or online airline reservation system, or it can be a library management system, right? So the things that we do in our day-to-day life, we want to make it more efficient, more, uh, what do you say, more, make our life more easy, so that we don't have
Yes.
to do all the manual work and everything is controlled and maintained by computers, right?
Right. Right.
So these day-to-day life that we, day-to-day work that we do, we convert that into programs to make things simpler for us. Now, whatever do we do in our day-to-day life, they are all centered around certain objects. For example, if you take a banking system, online banking, right? So even when there were no softwares, you had registers which the banker maintained, and anybody who opened an account, they would make an entry into the register saying he deposited some amount of money, or he withdrew some money, or if there was a loan that he took. They used to maintain all those records on book and paper, right? So what we did is that we thought that why not have those in programs, so that we don't have to have those manual entries, and we represented that register as an entity or as an object in our program, right?
Right.
So everything that we write in a program is to represent a real live, real-time scenario, bank or reservation or library. So that is why all of these real-time scenarios have certain entities inside it, which we represent as an object in our programs. So that is why you cannot have, or it's more, your programs are more structured if they are centered around objects, because they are written to represent a real-time scenarios. Real-time scenarios are based on some entities and hence objects, right? So now coming to the next question, that what are the different, or rather, what is an object? So we already saw that any real-time entity is an object. Any real-time entity will have certain features. For example, say car. So car will have a color, doors, wheels, engine, right? How much, what's the power of engine? So these attributes or these features are termed as variables in our objects. So when you represent that as an object, you'll create certain variables inside it, which will represent these attributes of the object. And then along with that, the objects or the real-time entities, they also perform some certain operations. For example, the car would move, the car would, or the
door will open, for example.
yeah, door will open, etc. So these are different operations that will be performed by the car, and to represent these operations that objects perform, we create what we call as methods or functions inside the objects, right?
Right.
So these are the concepts around objects, and we represent that as a program, and when we represent as a program, we call that as a class. All right. So you might have heard of this. You might have heard of the term class.
Okay, class. Yeah, correct.
Right. So objects are theoretical terms, terminology to represent these real-time entities. But when we go down to write as a program, when we represent these objects as a program, we call them as a class. So a class is nothing but it is a programmatical representation of an object.
Right.
So you'll create a class, and inside the class you'll create all those variables and the methods, which are nothing but the attributes of an object and the operations that they perform.
Clear.
Okay. Now so this is like the basic of what is object and what is a class. But apart from this, there are certain other concepts that are required for any programming language to follow if they say that they are object-oriented programming language. Okay. So obviously they need to have objects and classes that you need to write in those programming languages. But apart from that, it should also support certain concepts or certain fundamentals as well. So those fundamentals are these, right? So you already talked about classes and objects. The others are encapsulation, abstraction, inheritance, and polymorphism. All right. So these are 4 other pillars of object-oriented programming language apart from objects and classes.
Mm-hmm.
Right. So have you heard of these terms?
Yeah, actually I've heard about most of these terms, but basically like encapsulation, I heard about it a lot in networking classes, and abstraction in programming, inheritance in programming, polymorphism in programming, and security as well.
Perfect. So how about instead of me telling you about them, you tell me what you understand by encapsulation, abstraction, inheritance, and polymorphism. And then maybe I can put in my points wherever you differ.
Okay, so encapsulation is basically we are putting everything in one package instead of, yeah. And abstraction is like instead of going through all details, we deal with the whole idea. Right? Inheritance is like to bring some classes or attributes from another class. Is that right? I'm not sure about this. Polymorphism, yeah, polymorphism is like doing something grow. I'm not sure. I forgot this concept now.
All right. So you are perfectly correct in the first three, which is encapsulation, abstraction, and inheritance. Now, having said that, it would be good if you can give me some examples as well on these three.
Yeah. Encapsulation, like I didn't have any example in mind. Encapsulation.
A class is an example of encapsulation, right?
Yes, because we put everything into that class. All attributes will be in that class, right?
Exactly. So that means now that brings us to the idea from where the classes came into picture. So in programming language, we said that we need to create classes, and then I said that these are the 4 pillars of object-oriented programming concepts, right? So the first pillar is, so classes came from this first pillar of, or rather the first concept of object-oriented programming, right? So if you have a programming language which says it is object-oriented programming, it has to ensure that it provides encapsulation, and encapsulation can be provided using classes. That is why all the programming languages, whether it is Java or C# or C++, any programming language, if they ensure that they are following the object-oriented concepts, they will all have classes in them.
Right.
Okay. All right. How about abstraction?
Abstraction, instead of writing the whole details about the function, for example, we just focus on the main function. Right?
I doubt.
Can you tell me what is the best answer for that?
So abstraction is hiding the details and showing only the details which is required to be exposed to the external world. That's what abstraction is, right? So abstract means showing only the required details to the external world and hiding all the inner details. Okay? So now if you look at a class, when you declare variables, you might have noticed you write certain access modifiers such as public, private, protected.
Right.
Right?
Yeah.
So these so these access modifiers basically tell whether these variables will be available for an entity from outside the class to access it or not. All right. So if it is a public variable, you can access it from outside the class as well. If it is private, you can access only from some methods inside the class. You cannot access it from other, right, outside the class. If it is protected, it won't be available to be accessed by entities outside the class, but the children can access it. So if it is private, even the children cannot access it. So if you have a parent class and you have created a child class from the parent class, which is concept of inheritance, then you said that all the attributes of the parent gets available inside the child as well. That is what inheritance does, right?
Yeah.
But if the variables are private, then they won't be available inside the child as well. Okay? So only the public variables will be available inside the child. Now if you want to have those variables available to the children, the only option is that you make them public. But if you make them public, they become available to all other external entities as well, which is a risk. I don't want those to be available to others.
Yeah.
So in that case, there is a third access modifier called as protected. Okay. So if you say protected, then it acts as a private for external entities, but for the children, it acts as public. So the children will have them just like the public variables are available to them, but it won't be available to the external entities.
Right? That sounds great.
So, okay. So that's about abstraction. Now inheritance we already discussed, right? So you have
Yeah.
a parent class and the children will inherit all the attributes and methods which
From the
are either
parent.
public or protected inside the parent.
Mhm.
Okay. An example of it can be, say, you have a person class. So a person will have a name, age, he will perform various operations like walk, eat, work, etc., etc. And there can be other classes as well, such as student or an employee or a teacher, so who are also in turn person itself, right? And obviously all those details that you declared inside the person class would also be available with these entities as well. For example, an employee will also have a name, age, he will also walk, eat, etc., etc., right? So it
Yeah.
makes sense that instead of writing all those in the employee class or the student class as well, you can simply derive all those attributes from the parent inside the child. So you don't have to write them again and again, right? You have already written in the person class, it will come inside the child class as well,
Child class.
isn't
Yeah.
it?
Correct. Yes.
So that's about your inheritance. So it helps you in reducing the amount of code that you write, right? It helps you in structuring your code in better manner. So tomorrow if somebody sees your employee class, exactly looking at the class, he can say, hey, you know what? Employee is related to the person class, right? So it helps you in building kind of relationship, relating objects with each other.
Mhm.
So your program becomes more understandable, more reasonable, right? Amount of code you need to write is less. So, so these are certain benefits of inheritance. And polymorphism is actually formed by two words called poly and morphism. Now poly means many and morphism means forms. That means some entity having many forms. The same entity can have multiple forms. And what we mean by that is you might have heard of terms called as method overloading or method overriding. Have you heard of these terms? Method
Method. Method
overloading
overloading and method what?
and method overriding.
Overwriting. I've heard about this. Yeah.
Right. So these two are the examples of polymorphism. Okay. And let's just walk through the slides. In one of the slides we have the examples, so that will give you better idea. We have a small code snippet to make you understand. Right. So just we'll quickly walk through the slides, and then when we reach to that examples, we'll discuss them in more detail. So, like we said, object-oriented programming is a design philosophy. That is, it's a design philosophy in the sense it's a construct based on which different programming languages are built, right? So it's a design philosophy and stands for object-oriented programming, which you already saw. What are objects? So anything that really exists in the world, for example, a table, car, dog, etc., etc., they're all objects. An object has properties, it has some actions, and an object would have some responsibilities or operations that it might perform. Why do we care about objects? So, like we discussed, everything that we write in programming are written to represent real-time entities, and it makes sense to have these real-time entities represented in your programs. Apart from that, these are the other benefits that you get if you create programs out of objects. First is modularity. Now, modularity means your program are broken down into smaller pieces or smaller modules. And the benefit of having your program broken down into modules is that you can have these modules reused in different other programs as well. For example, say you created a person class, right? For say XYZ project, you created a person class. Tomorrow, you are creating some another project, and you find that in that project also you have to create a person entity. So you can simply copy this code and reuse over there. You don't have to write everything. So creating objects helps you to reuse those entities in your projects or in different projects. So that's the benefit of modular programming. Reusability, again, programs can be assembled from pre-written software components. So you can create modules So these two are interrelated, modularity and reusability. Okay, and extensibility. So you have the concept of inheritance, where you have created a parent class, and tomorrow you find that you need to create another entity which has some of the functionalities from an existing class or an existing object. So what you can do, you can simply create a new object which will inherit those properties from the parent, and it can have some other attributes of its own, right? So you have created a new object where you did not have to write the already written code. You had reused it from other object, and you can also add your own functionalities. So it gives you the flexibility of extending your code in whatever manner you like, right? So new software components can be written or developed from the existing ones. Okay.
Right.
So these are some other benefits of having object-oriented programming concepts. Now classes provide a structure for your object. It is like a blueprint, right? So if you have seen a blueprint, they are like framework of any design that you create. For example, blueprint of a building will have the outer structure or the framework, how the building has to be built. Similarly, a class is like a blueprint, so it represents the structure of an object. It does not exist physically, right? So we already discussed that in your programming language you actually represent objects as a class. So obviously it doesn't exist physically, but it is just a representation of an object inside the class. But make this thing very clear that a class is not an object. Many people confuse saying that a class is an object. So class is not an object.
But
you should fix this in your mind. It's just a representation of a class. It's just a blueprint. Now an object, you need to create an object out of a class, right? So it's just a blueprint, right? So a blueprint of a building will be what? In a paper there will be a drawing. But that's not the building, that's just the blueprint. So the building only becomes when you create the actual building by your brick and mortar, isn't it?
Yeah, so you mean if you just created a class without any attributes and properties, that will not be an object.
Even if you create a class with attributes and methods inside it, it is still not an object. It is still a class. It's just a representation. An object is only created if you use this class and create an object. And we create an object using the new operator. We write new followed by the class name.
Yeah, got it, yeah.
Right? So when you use the new operator over a class, only then an object gets created.
Right.
Till that time, the class has no literal meaning in the program. It's just a representation, it's just a file. Okay?
Yeah.
So have that concept very clear in your mind. Many people get confused. They think that a class is an object, but a class is not an object. Okay? Okay, so an object is combination of data and methods which we discuss. An object has the responsibility to know and the responsibility to do. Obviously, right? So it knows what it has to do and it knows how it has to do it, right? So you'll have those methods where you'll write what are the operations that the object will be doing and how it will be doing. Coming to encapsulation, so wrapping of data and functions in a single unit is known as encapsulation. It is also known as information hiding, right? Because we are enclosing all the details inside a class, so those details get hidden from the external world. It's up to you whether you want to expose them or not. It is way of implementing abstraction, right? So abstraction and encapsulation are interrelated, right? So you encapsulate things inside an class and you add those modifiers and implement abstraction on top of it, right? So this is just an example of a class which says this is the class whose name is A. Inside that you have a variable called A, and there are these two methods to get and set the values of A.
Right? Can you go through this very quickly, please?
Yeah. So in order to create a class you have to use a keyword called class. So we'll go through the programming concepts later on. So it's fine if you don't follow it right. It's just a representation which is that there is a class called class A. So to create a class we use a keyword in Java called class, followed by the name of the class. Right? So this means this entire program is a class A. and inside the class you have attributes. So attributes are represented by variables. Okay, so the variable inside this class is what? A. A is a variable of type integer.
Integer.
Int stands for integer.
Yes.
That means the variable A can store numeric values inside it.
Correct.
Okay, and then you have created two methods here. If you see, one method is used to get the value of A, another method is to set the value of A, and methods have the access modifier public. That means they are available to the external world as well. So anybody who wants to get the value of A from class, right, they will call this method, and this method actually returns the value of A. So you have this statement called return A. So whatever is the value of A, it will return that value to whoever is trying to access the value.
Right.
Similarly, if somebody wants to set the value of A, he cannot access A directly. Here if you see, there is no access modifier given. It's directly int A. So if there is no access modifier given, then automatically Java makes it as private. Right?
Okay.
So don't worry if you don't follow it. When we go into the programming, then we'll get it.
Yeah.
Right. So we can just bypass it for now because we are just focusing on the object-oriented concepts. So we'll just pass it, okay?
All right. Okay.
All right. Now next comes abstraction. So data abstraction refers to providing only essential information to the user and hiding the unnecessary data from the user. Right? This is again another example of a class called bank. So we are trying to represent a bank here, right? And we have created again a class. So Java has a keyword called class. So if you want to create a class, you will use the keyword class, right? And the name of the class. So I want to represent a bank entity, a bank object. So I'll create a class called class bank. All right. So what are the different attributes of a bank? Account number, account number, name, balance, right? So all those attributes we have declared here, see, and we have given the access modifiers as private, and the type of values that they will store, right, and the name of the variables. So, so that's how you create the attributes.
Yeah, that's clear.
That's clear, and then you will have certain. And then you'll have certain methods inside it, which are nothing but some operations that a bank will perform. For example, a bank will perform a functionality of displaying the details of bank to the clerk. So that is why we have a function whose name is display to clerk, right? And you can write all your code in here, how it needs to display the details and other things. So you created a function and you wrote the details here. Similarly, there is another function called display. So if you call, because the bank will also display the details to the customers as well. So if the customer want to see the details of their account, they can simply call this function called display. And in the display function, you'll write your code to display the account details. So basically a bank has set of attributes and set of operations that it performs. So whatever set of attributes it has, you declare them in this manner that we have done here, and it also performs certain operations, one of which is to display the details to either the clerk or to the employee or to the account holder. Along with that, you can also have other operations like deposit money, withdraw money, right, take loan, etc., etc. So you can create methods for all those operations as well.
Right. So can you go back please to the
yes,
right?
Yes.
Okay. So what's the less than sign? This is just for clarification, not for
It's just for clarification. Okay. Yes. It's not an actual code.
Okay.
It's just a representation.
Okay. Got you. Okay.
The only takeaway from here is the name of this function.
Right.
So it's public. That means it's a function which we want others to be able to use, right? Because if you make it private, there's no meaning of creating the display function. If nobody can call this function, there's no meaning of creating it then, right? Nobody can call it and nobody can see the account details. So that is why we made it as public. Similarly, the display function is also public.
Right.
So moving to inheritance. So like we discussed, inheritance means one class inherits the characteristics of another class. It is a mechanism of deriving a new class from an already existing class. This is also called as relationship. Now this is very important sentence. Um, this sentence may seem meaningless as of now, but later on when you go, you go into architectural position where where you have to design your program or project architecture, etc., then you may come up into situations where you have to decide whether the class that you are going to create, should it be a child of another class or not.
Right.
When do you decide that you need to create a child class or a parent class and so on, right? There has to be some way to decide. You cannot
Yeah.
simply create some class as parent, some class as child, blah blah blah, right?
Right.
So this sentence over here helps you in deciding whether you have to create a parent class or a child class, or you can simply create two different new classes itself, irrelevant, not related to any other classes, right? So that choice can be made by this sentence. So how this sentence helps you in that is, say I was talking about the person, an employee and a student, right? So ask yourself a question whether an employee is a person or not. An employee is a person or not.
Right.
A student is a person or not.
Yeah. All are persons.
So all are person, right? If you get your answer as yes, that means you have to create the employee and student classes as child of the person class.
If they are if they are in the same type, you mean, right?
Same type, same type. So if it is followed by the word is a, so when you create the sentence, right? Employee is a person. So you have this word is a, that means it is a child. Don't think anything, make it as a child. But if I say car is a person, so what is your answer?
No, that is not a child.
So that means you cannot create car as a child of person class.
Right.
Okay.
It's, okay.
So whenever you are in doubt, just think of question.
Yeah.
Is this thing a person, or is this thing a employee? And if it is, your answer is yes, then go ahead and make it as a child. If no, then you create a separate class for it.
And should we also like figure out if this relationship is many to many or one to one or one to many and etc.?
In Java you don't have many to many and one to many. You always have one to one.
Okay.
Yeah.
Yes.
So Java doesn't.
I was thinking
Sorry,
I was thinking like a database, but it is not. The same. The main reason here is that we have parent and child, right?
Yes. So there is a reason because of which Java does not support multiple inheritance, right? So in C++ you have multiple inheritance, which means, say employee, right? So employee you can have manager and CEO, etc., other roles, right? So they are also employee, isn't it? So what happens is that if you create two different multiple hierarchy, like one class actually extends two different classes. For example, say the employee now also has two parents, right? So it is extending the person. Say it also extends some other class. Say, let's say, what other class can it extend?
The student, you mean?
Okay, let's talk about a student. So a student is a person, right? At the same time, a student can also be working somewhere as a part-time,
right?
So he is also an employee. So what will happen? You will create the student as a child of person as well as a child of employee class. So you'll have two parents for the student class, right?
Yes.
At the same time, employee is also a person, correct? So that means the student class will be deriving the name and address from the person as well as from the employee class. So actually your student class will be having two variables with the same name called name and address. Once it will be coming from the person class, and second time it will be coming from the employee class, isn't it?
Yes.
So isn't that complex? Now tomorrow if I want to access the variable called address from the student, I don't know from where to access it, whether the address that I'm trying to access is coming from the person class or is it coming from the employee class. I'm confused, right? So that is why in order to remove these kind of confusions, complexity, Java says no many-to-many relationship, no one-to-many relationship, only one-to-one relationship. That's it.
That's easier.
That's easier and it removes all those long-term complexities,
Yes.
right? So but in C++ you have that, and that is why at some point of time you don't keep track of these things, your program becomes a mess.
Yes.
Okay. So
I mean, the attributes under these entities is not necessarily to be the same, right?
yeah, it's not necessary to be the same.
That's okay.
You can give any variable name, anything. It's all up to you.
Okay.
So it doesn't mean that a person should only have name. You can give some other variable name as well. Okay. So that's up to you. It's just a name, so you can give any name that you want.
Okay. Okay.
So along with is a relationship, there is also something called as has a relationship. Can you guess what does has a relationship mean?
Like the child has a relationship to the parent.
So I'll put it in this way. Does student has a person?
No.
Does employee has a person?
Then no. You can't say
Okay,
that.
now let me ask you this question. Does person has an address?
Yes, sure.
Yes. Now address itself is an entity, isn't it?
Yes.
An address is in itself an object because an address has name, street number, flat number, society number, country, state, zip code, phone number, etc., right? So there are different attributes of an address. So an address is not a single entity, but it's an object actually. It has its set of attributes, right? So to represent an address, you will create a class, correct? So at the end of the day, you have a person class and you have an address class, okay? But you found that a person has an address. That means somehow you have to relate your person to the address, or rather somehow you have to relate your address class with the person class. But you cannot have a parent-child relationship between them because a address is not a person. But a person has an address. Then how do you represent that? So to represent that, what we do is we create a variable inside the person class of type address. Right now, you see these, so if you go to your classes, you see these variables that we have created, these are of type integer or of type string or of type float, right? Because they are going to store values of type integer or string or so on.
Right.
But if you are going to store value which is of type address, then what you do, instead of having int, string, float, you can simply write the name of the class, that is address. Okay? So that means your person class is going to have a variable which is of type address.
So we should define the type address before we put it here, right?
Yes.
Okay.
So defining the type, when you create a class is also a data type. So the moment you create a class, it becomes a type also. So you can use that to create a variable. So you can simply write address and the type as address. So here you can write it as private address and the name of the variable. You can give address or whatever name that you want to give.
Okay.
Okay. So it becomes, so that is the representation of has a relationship. So whenever we encounter a situation where we have to decide whether you have a has a entity. So there are two classes and you come up with the scenario where you are using the word has a, right? Person has a address. That means you have to create a variable of type address inside the person, or you can say uh, customer has an account, right?
Mhm.
So account is in itself an object. So account will have account number, balance, and different methods to withdraw money, etc., etc. But customer will have a account, right? So that means there has to be an object of type account inside the person, inside the customer class.
Okay.
So you'll create the customer class in this manner. So you'll write it as class, right? And inside this you'll create a variable called private
Mhm.
account. So this is a variable ACC which is of type account,
Okay.
and account in itself will be a separate class
Okay.
which has its own set of features like int,
Account
account,
number. No,
number, balance, etc., etc.
yeah. Yeah. That's
Right?
yeah. That's
So
clear now.
this thing has a relationship. Why?
Mhm.
Because customer has an account. Okay.
Mhm.
Similarly, if I say customer is account,
No.
then it would be so it's a no. But suppose if customer is an account, then we would have written it in this manner:
Mhm.
class
Customer.
customer extends. So when you create a class called customer and say extends account, that means customer is an account and it is extending the account class. Extending the account class means I'm creating a child out of it. So parent would be account and children will be the customer, because the customer is extending the account class, right?
Mhm.
So extending means it is deriving some features from some other class.
Mhm.
So account becomes parent and this becomes children. So this is how you represent the inheritance is a relationship, and this is how you represent the has a relationship.
Right.
Alright? So these two terms are used when you design your application and you have to decide whether you have to create a parent class or a child class, or you have to create a variable of a class inside another class, right? So these concepts basically help you in deciding those factors. Okay?
Great.
Now coming down to polymorphism, so we discussed that polymorphism means having many forms. It allows different objects to respond to the same message in different ways. The response is specific to the type of the object. So obviously if the same thing has different forms, means it will respond to different messages in different manner. The same thing will respond to the same message in different manner, because obviously it has different form. Now polymorphisms is of two types. If you look at this diagram, so one is compile time polymorphism, second is runtime polymorphism. Now under compile time polymorphism you have again two divisions, which is functional overloading and operator overloading, right? So I was talking about function overloading, right? So function overloading is an example of compile time polymorphism. At the same time you also have operator overloading, which is again example of compile time polymorphism, but Java doesn't support operator overloading. Operator overloading is a concept which was supported in C++, but again in order to reduce ambiguity and confusion, Java doesn't support it. But I'll explain you what operator overloading is. So if I ask you this question, what are operators?
The
Do you know
operators
what
are
are?
like, yeah, sure. It's like
Yeah.
Plus, minus, multiplication.
Exactly. All right. Now, when I overload an operator, that means I'm changing the normal behavior of plus and making it something else, right? Overload means what? Overloading means it's an example of polymorphism. Polymorphism. That means same thing having multiple functionalities. Now, your plus is used to add two numbers, right? 1 plus 1 equals 2. How about you overload its functionality and change it in such a manner that if somebody writes 1 plus 1, it is not 2 but it becomes 11.
Mhm.
Isn't that confusing?
Yeah, sure. That's concatenating, actually.
It's concatenating. And what you did is that you overloaded it and changed it meaning itself. And tomorrow if somebody doesn't know that you have overloaded it, he will by mistake, instead of adding, he will concatenate and add to confusion. So Java said, I don't want all these things. If somebody wants to add two numbers, he can create a function called add. That's much better, isn't it?
Yes.
So Java doesn't support operator overloading due to these ambiguities. So in Java we only have function overloading, which is an example of compile time polymorphism. And function overriding is an example of runtime polymorphism. So it's not written over here, but I'm just telling you that function overriding is an example of runtime polymorphism, overloading of compile time polymorphism. So this is a very important question which are asked very often in interviews and etc. So you should keep that in mind. Okay. Now function overloading is over here, that is given. So two or more function with same name but different function which is differentiated by the signature. So two or more function having the same name but they are different from each other just because of their signature. The signature of a function is this line. I'll just highlight that here. Oh, I cannot highlight. Wait. Let me just type it here then. So in this example, right, void add int A int B. So this line, right, this line is called as the signature of a function. Okay. So the signature of a function is formed by the return type. So this is called the return type of a function.
Yeah.
This is the name of the function, and these are the parameters that you are passing to the function. Okay. So all together forms the signature of the function. So if the name of the function is the same but the signature is different, then it is an example of method overloading. So you see here the name is add for both of them, but the signature is different. This has two attributes, this has three attributes. Three parameters. Right. So this one is taking two parameters and it is adding those two numbers and returning the result. This one is taking three numbers and adding them and returning the result. Okay.
Right.
But the name is same. So if somebody calls the function add and passes two parameters, then it will automatically call this function and add the numbers. If somebody calls the function add and passes three parameters, it will automatically call this one and add the numbers and return the result.
So this is overloading, not overwriting, right?
Yes, it is overloading because it is compile time polymorphism. And why it is compile time? Because when you are writing the code, that time only you have written these two methods and your compiler knows that there are two methods with the same name with different signature. Your compiler is aware of it.
Yeah, so now I have a question here. What if we have like the same function but the second one has count A minus B and it has like just two parameters in it?
Doesn't matter. So you mean to say inside the function you have A minus B?
Not this one. This one is the same, but the second one we have two parameters, integer A and integer B, and in the count we have A minus B.
That will be an error.
That
because
will
I
be
told
an
you,
error.
because
so
I told you it only looks at the signature. It doesn't look at what you have written inside the function.
Okay, so the signature, if the signature are the same, so it will not be compiled.
Yes, it will give an error. Because why I'll tell you. Say you have written two functions with the same signature. Now somebody calls for function add and passes the two variables. How will Java know? How will Java know that which one to call?
Yes, there is like two
Isn't it?
same signature. Yeah, two signatures. Two same signatures.
It's a confusion, right? Java want to know that which one to call. And if it doesn't know what to call, obviously it will go mad.
Yes.
Anybody will go mad, isn't it? So it's logical. It's logical. There's nothing to...
Correct.
Correct? So that is why it won't work.
Mhm.
So
But if we keep the signature like the second signature is integer a, integer b, and integer c, that means we should enter three parameters
yes,
in the input. I mean,
yes,
right?
yes.
If
So
if we enter just two parameters, what will happen?
if you just enter two parameters, then it will call the one with two parameters.
Mm-hmm.
If you enter 3, it will call the one with 3 parameters. If you enter 4, it will give an error saying, hey, I don't have any function which is taking 4 parameters.
Okay, okay, okay,
Okay? And
okay.
it is not necessary that both the variables has to be integer. So say you have a function called add which has integer a and integer b, and you have another function called add which is integer a and float b.
Yeah.
Even that is correct because the signature is different now, right? The second one is taking two
Okay.
variables of type integer and float. The types are different, so that means the signature is also different.
Right, I got you now. That is very good concept that you need to keep in mind. So in this case, you said like in function two integer a and float b or double b, for example. Then we said a minus b.
I mean, whatever you write inside doesn't matter. Inside the function, whatever you have written doesn't matter. You write whatever you want. Under function overloading, it doesn't even look at what you have written inside the function. It only looks at the signature.
Yeah, but
right?
but we will still have like the same parameters a and b's, but one a plus b and the second a minus b.
Doesn't matter.
Because the second one will be represented with like double or float because we have float signature in it, right?
No, it doesn't matter. So see, I'll explain it again. So if you look at signature, you know these variable names, Java doesn't care about what name you have given.
Yes.
You know, for Java,
I
this
know.
function signature is actually this.
Yeah, integer or
Right.
the type. It focuses on type.
On type, because variable name can be anything. So Java doesn't even care what name you have given to the variable. It just
Yeah.
looks at the type. So this and these are two different signature for it. It
Two
won't
different
complain.
signature. Correct.
And inside this, whatever you are doing, you know, you do A plus B, A minus B, A into C, whatever you do, it doesn't care at all, right? It doesn't care. It just looks at these two lines.
Okay. Okay. Got you now. Okay.
Yeah. So that's function overloading. Now coming to method function overriding. Now function overriding comes in scenario when you have inheritance in the picture. So I'll explain you how does that come in scenario. So say I have a class called person, okay? Sorry, we'll write it.
Yes.
Person, and say person does some work, right? So I'll create a method inside it called work, right? And I'll say does some work. We don't know what work it does, but it does some work. I've just written some dummy line here, does work, right?
Okay.
Now if I create another class say student, okay, and I say student is a person, right? So I'll say student class A extends person.
Persons.
So automatically now student has this method inside it. Student will have this method inside it automatically because it is extending the person class, and the person, whatever thing the person might be having, it will be available inside the student also, isn't it?
Yes.
But if I create one more class, say employee, so employee is also a person, isn't it?
Extends. Yes. Extends. Persons.
So now employee class will also have the method work inside it,
Yeah.
and it also does work.
Yeah.
Now can both student and employee do work?
Yes, sure.
But what is the work that the student will be doing? The work for student is study, isn't it? and the work for its employees maybe carpentry or programming or whatever, right?
Yes.
He might be a sailor or he might be a mechanic, anything he can be, pilot or whatever, right?
Correct.
That means I cannot represent this function work by giving a generic statement inside the person class.
So we should have like variables here, right?
No. So what I can do is, but a person does a work. So I need to write this method over here. But if I write this method over here, automatically this method becomes available inside the person and the, inside the student and the employee class also. And by looking at this, it appears that both student and employee are doing the same thing.
Yes.
Which is not true, right? So what you can do is, you can write the same function inside the student and inside the employee also. And here
we can change
you can write study, and here you can write, say, programming. It's just a representation. You'll actually be writing some code here, so we'll see that when we go into our programming concept. So it's just a representation, right?
Yeah.
What I have done is, even though there was the method was coming from the parent, I rewrote the same method again inside the child classes, and inside the function I wrote whatever the particular class was doing. For example, if the student was doing study, I wrote study, and if the employee was doing some programming, I wrote programming.
Yes.
Question. So now,
go ahead,
right, so this is clear till here, isn't it?
Right.
Now if I ask you, how many methods called work are present inside the student class?
In this one?
Yeah, in the student class, how many methods with the name work are there?
It's
inside
just
the
one.
Student class.
It's just one.
How?
One method.
One that you have written here, and the another one is coming also, isn't it?
Yeah. But is it different because we just like copied the method because it's the same method, right? Yeah.
It's the same
so we
method,
have
right?
Yeah. I thought it's a different name, but yeah, we have two methods now.
Right. So in the student class now we have two methods with the same name, right? But during compile time, when you are writing this code, your compiler won't know this. You know, for the compiler it looks like this class has only one method. Yeah.
Yes.
So it doesn't know. It will say, okay, this has only one method. The compiler won't complain. It's all perfectly fine.
Yeah.
But during runtime, during runtime when you will be running this code, and say you write something like student s equals new student. You created an object of student, right? And you say s dot work. So I'm calling the function called work.
Yeah.
So now when you call work, which function will it call? Will it call this function or will it call this function? Confusion, isn't it?
This might be confusing, yeah.
Right? So this is the point where Java has to decide which one to call, whether to call this one or whether to call this one. Right? So at this point, your Java gives preference to the method that is present inside the child. Okay? So instead of calling this one, it will call the child method. Okay? And this is known as, sorry?
But how Java knows whether it is a person or student here?
Right. So you declared this variable calling as student, right?
Yeah.
So now s is the variable of type student.
Right.
Right? And I'm saying call the work function which is present inside the student.
And this method is called from the student, right?
Called from this student.
Okay, got you.
Okay? So even though a student has two methods with name work, it will call the one that is present inside the student instead of calling the one inside the person.
Okay.
Suppose if this method was not present here, and then if I write s.work, then it will call the work method from the person one.
But how it will call that from the person we have like s dot work, because s refer to student here.
Because student is a child of person. So
Oh
everything
yeah.
that is present inside person is present inside student also.
Okay, okay, that's perfect.
But if you have the same method inside the person also, then in that case Java will give preference to the function that is there inside the
yeah, the new object.
yeah.
Okay.
Got the concept? So this
Got the concept.
logic is known as method overriding.
Method what?
Overriding.
Overwriting. Okay, overwriting. Okay, I heard you now. Okay.
Overriding.
Okay.
Right?
Okay.
So there are two concepts: method overloading.
Overloading and overriding.
So overloading is during compile time, and that is present when both the methods are present in the same class. Okay? And method overriding is during runtime, and that happens when the methods are present in different classes. One method would be present inside the parent, other would be present inside the child. Then it is method overriding, and it happens at runtime. Because when your program will be running, that time the Java will decide which one to call.
Right.
Okay? Whereas method overloading, it will know only during the compile time only which one to call, because it's already there in the same function. So it knows what are there in the function. So that's method overloading. So these are two important concepts. So just keep those in mind.
Yeah. Please keep this a little bit. If you can you please keep it?
Sorry.
Can you please keep it? I have a question on it.
Yeah, go ahead. Ask the question.
Yeah. So now I have two questions. First, now each method in the void work, we don't have any like public or private, so it will automatically be private, right?
Yes.
Okay. Okay.
It will be private.
Okay. So now how? Okay. Okay. Now I got the answer, but I will ask it anyway. So how the child
won't have. It won't have.
Can access. Can access.
It cannot access. It cannot access. You have to write public.
I have to write public, right?
Yes. Yes.
Okay.
Yes.
Okay. Okay.
I did not write it. I did not write it.
Because
but good thing that you noticed it.
Okay, that sounds perfect. And the other things is, isn't it like more like efficient, or like let's say it's more easier to write if statement inside the parent class for the method, if work, or if let's say if
okay, hold that question there. I got your question. I'll answer it to you.
Okay.
How many type of persons are there? Student, employee, clerk, customer, teacher, women, laborer. You know, there can be n number of child classes that you can create. How many if statement do you think you will write?
For each one.
Come on, isn't it? So it becomes complex.
It's very complex.
Right?
Okay. Okay.
It becomes complex and unmanageable. And at the same time, anyway, you will be creating the student class and the employee class. So it makes sense that the work that they do is written inside their class rather than written outside in some other class.
Yeah.
Because
so it can be done, but it is not so efficient, right?
Yes. Yes.
Okay.
So the whole idea of creating the object was that the code related to an entity remains with it. It doesn't. It's not separated here and there, right? So if you do that, you are breaking the first principle of object-oriented programming, which is encapsulation.
Right.
If you do that, you break the first principle of object-oriented programming, which is encapsulation. Right? You are sending the attribute of an object outside the object, which is wrong, isn't it?
Yes.
So you can do that. Obviously, nobody will stop you, but you will be breaking the first principle. Even there is no hard and fast rule that this is the principle you have to follow it. But the point is that in long run, your program will become mess. So the whole idea of creating this principle is that you create programs which are efficient, maintainable, durable, easy to understand, etc., etc. So all those idea will crash.
Yes, yes. That
Because
is perfect.
C doesn't have all those things. So that doesn't mean that nobody writes programming.
Can you still, okay, it's gone. Okay, no problem. Okay.
Oh,
I
sorry,
got
you wanted to
is
ask
that,
something
no, 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 it's okay, it's okay. It's okay. So I got the concept. Just I want to read something, but it's okay. I got it. No problem.
You can ask me if there is something that you want to ask.
No, I would ask you if I will have the slides, the PowerPoint slides, and like if we make materials here, like because it's good to follow up with you rather than taking note, because I was taking note all the time.
Oh, I'll be sharing you this slide, so you can
Okay. Okay.
follow this slide. And I think Asim might be sharing the video as well with you. So I mean, all the discussion that we have done, you can also listen and
Okay.
go through it later as well.
Perfect.
All right. So okay, so today we'll be ending our session with this note. Tomorrow we'll start with basic concepts on what is Java, what are the small concepts about Java, and we'll take it forward from there. Yeah.
Okay. Great.
Meanwhile, I would suggest do some reading over this OOPS concept, right? And if you have any questions, we can discuss that tomorrow when we start the session.
For sure.
All right. Perfect. Have a nice day then.
Thank you. Nice to speak with you today, Jake.
Thanks.
Okay.
Yeah.
Thank you. Goodbye.